I'm Qifeng from the College of Animal Science and Technology, China Cultural University. I would like to introduce a recent study published in iMeta entitled Quantitative Microbiome Profiling Reveals the Developmental Trajectory of the Chicken Gut Microbiota and its connection to host metabolism. Let me introduce the background of this study. Chicken meat had become the most consumed animal meat worldwide. Chicken gut microbiota strongly influences immunity, nutrient digestion, and feed efficiency. Mostly, many focus on the characterization of the chicken gut bacteriome, with less effort to rebuild the fungal community. The development of the gut microbiota during the early life has a far-reaching impact on host health. Compared with relative abundances that are used to profile the proportion of different microbial types across time and space, quantitative microbiome profiling concerns changes of absolute abundances, which allows us to elucidate the real community dynamics. The present study investigated the section of chicken gut microbial communities from the 4 segment to a 42-day protection period using quantitative microbiome profiling. We also use untargeted metabolomics to characterize the metabolite changes in chicken serum over time and construct the potential connection between the gut microbiota and the chicken metabolism. The following are the main findings of our study. We found that the absolute abundance of bacteria at foregut reached a plateau at 7 days post-hatch. The focal load was higher in the ileum than the cecum. The alpha diversity of bacterial communities was higher in the cecum than the other 3 gut segments, which is likely due to the dominance of lactobacillus in the foregut. The diversity of fungal communities was relatively less variable over time and space. To identify differences between the quantitative microbiome profiling and the relative microbiome profiling in chicken gut microbiota, we first examined the developmental trajectories of the predominant taxa at the phylum and genus levels. Significant differences in microbial development was observed at both levels. Compared with absolute abundances, relative abundance exaggerates the proportion of variation explained by the factors. The relative microbiome profiling approach was prone to overestimate the positive correlations for the bacterium and miss the positive correlations for the microbiome. We found that the chicken gut microbiota quickly formed segment-specific community types after hatching. We found a limited microbial transmission from the duodenum to the jejunum and from the ileum to the cecum. Only the jejunal microbiota contribute about half of the ileal microbiota. We found that deterministic processes played a more important role in bacterial communities, and stochastic processes play a more important role in fungal communities. We further assigned all the occurrence patterns that exhibited regular changes into 3 categories: colonization, disappearance, and co. There were 15 patterns in the colonization category. Some patterns contained 24 genera were assigned to the disappearance category. One pattern contained 18 genera belong to the core category. We constructed microbial co-occurrence networks for the 4 gut segments with different topological properties. We further analyzed the positive and negative associations of the genera in each network. Interestingly, the majority of the genera, including all of the keystone taxa, exhibited a higher proportion of positive association than negative association with other genera. We then performed a time-course untargeted metabolomics to understand the alteration in the metabolites in broiler serum. A total of 641 metabolites are associated with time and formed 6 different clusters. Metabolites in each cluster form different trajectory of abundance change. Finally, we investigated the correlation between the chicken gut microbiota and the serum metabolites. The microbe-associated metabolites were mainly from lipid and lipid-like molecules. We identified 11 metabolites derived from the gut microbiota and 16 metabolites derived from both the host and gut microbiota. To make a brief summary, the developmental trajectory of the broiler chicken gut microbiota is revealed by a quantitative microbiome profiling approach. The chicken gut microbiota display gut segment-specific community types and growth stage-specific microbes. The chicken gut microbes have different colonization abilities, forming different developmental patterns. The chicken gut microbiota development is associated with the chicken serum metabolite changes. That's all. Thank you.